All right, so in this section, we divide everything by unit to get a per unit cost measures, and then we look at how all these curves look like and see if we can get some generalizations on this. Okay, so the first one is fixed costs. Remember that our fixed costs don't change, and those are going to be equal always to $100. So to calculate the per unit basis, all we do, and it's called that the average fixed cost. The average fixed cost is going to be the fixed cost you have divided by the output on a per unit basis. Now notice that every time you do this, the fixed cost stays the same. What changes is output. So if you calculate the average fixed cost, you see that at the beginning they're going to be equal to 100 divided by the output, which is 40. They're going to be 250. But when you make more, they go down because if the fixed costs are fixed. You see the fixed cost per unit, the average fixed cost when you have 90 units is $1.11. And when you have 120 units, it gets smaller, 83 cents. And when you have 135 units, it's even smaller. So if you look at a graph, what's happening here is that every time you add more workers, your average fixed costs go down. Again, your fixed costs are fixed, and your workers are increasing. Your output is increasing. So if you put the average fixed cost in a curve with the number of sandwiches in the horizontal axis and the costs in the vertical axis, what you get is the average fixed cost curve, which should go down with more output. There's a very interesting application of this as it relates to natural monopolies and the reason we have monopolies controlling public utilities. I have a little video of that at the end of the lesson this week. But for now, all you have to remember is that since the fixed costs are fixed, the fixed cost per unit go down every time you have more unit because you're spreading the overhead among more people. Among more sandwiches. The average variable cost is a whole different story because the average variable cost will go up at some point because you're paying more workers the same money, and it also depends on how productive those workers are. So to calculate the cost per the variable input, again, what we're going to do is to divide the variable cost by the output. And if we do that, you see in the table, when you have one worker, you make 40 sandwiches, your average variable cost, your cost per worker is $2. And when you have 90 sandwiches, which is when you have 2 workers, your average variable cost is $1.78. But when you have 3 cooks, your average variable cost starts to go up to $2 per sandwich. Then when you have 4 cooks, it's actually $2.37, which is per sandwich. And then you have fixed costs, and it starts to go up at that point. So it kind of goes down at the beginning, but then it starts shooting up. And again, the reason for that is because of the diminishing margin of product. At some point, you're paying the workers the same money, but they're bringing you less and less output. And then finally, you can take those two measures, the average variable costs and the average fixed costs, add them together to get the total cost per unit, the average total cost. You can also calculate that by simply dividing the total cost by the amount of units. You get the same number. And the story should go, let's look at the numbers first. So you see that the first cook increased to 40 units, so the average total cost is $4.50 per unit. Then with 90 sandwiches with 2 workers is $2.89 per sandwich. And then with 3 cooks, which is 120 sandwiches, you have $2.83 a cost per sandwich. And then with the 4th cook, it starts going up. You see, with the 135 sandwiches, the cost per sandwich is $3.11. With 140 sandwiches, it's $3.57. And with 142 sandwiches, which is all the cooks, 6 cooks, it's $4.08. Again, it's not difficult to make that story, right? At the beginning, average total cost is made out of average fixed costs and average variable costs. At the beginning, both average fixed costs and average variable costs are going down. Average fixed cost because you have more unit, and average variable cost because your second worker and first worker were very productive. Now, at some point, the average fixed cost stabilized because they're just a certain amount of workers of units. And then at that point, 2 things happen at the same time. That and also the fact that your workers become less productive because they hit this diminishing margin of product problem. They're running into each other in the kitchen. And you're paying them the same. So at that point, your cost per sandwich is going to start going up rapidly, very quickly. All right? So the average total cost curve is going to go down, and it's going to reach a minimum, and then it's going to go up, and that should be the way you should look for any kind of operation that follows this problem of diminishing marginal product. And then finally, let's look at, well, before we do that, let's focus a little bit now on that lower point, the lowest point of the average total cost curve. What does that mean? Well, in the table, that's $2.83, right? So when you have 3 cooks, you make 120 sandwiches, and at that point, your cost, at least from the numbers from the table, your cost per sandwich is $2.83. That is the lowest cost per sandwich that you are able to get in this operation. The way you're doing your stuff, the most efficient point that you are is when you're producing at a cost per unit per sandwich of $2.83. That's not when your costs are the lowest. That is when your cost per unit is the lowest. Which means that if your cost per unit is the lowest, it means that you're doing this in the best possible way. You're using your resources in the best possible way. And per unit, they are the cheapest that they're going to be. So that is that lowest point of that average total cost curve. Well, as it turns out, if we put the marginal cost curve, which we actually had calculated in the previous section, in this diagram, you will see that this marginal cost curve is going to cross the average total cost curve at precisely that point. That's no coincidence, it's a mathematical property. Now, I told you what the importance is of that lower point of the average total cost curve. Now let's see if I can explain the intuition as to why the marginal cost curve crosses that point at the lowest point of the average total cost curve. Well, think about your average for a class. So you're taking a class, and your average in the class is 80%. And then you take another exam, the marginal is the other exam, and you score 85 on that exam. So your average in the class is 80, and your change, the next exam, is 85. What's going to happen to your average in the class? It will go up. Because the marginal, the marginal change is pulling the average in that direction of the marginal. When the additional exam, the marginal, is higher than your average will go up. It's going up. Now, let's say that you have 80% and your next exam is 70. Now, what's going to happen to your average in the class? Well, it will go down, right? Because the next exam is 70, your average of 80 is going to be pulled down by that change of 70% in the exam. The same thing with costs. When at the point in which marginal cost is lower than average total cost, the marginal is pulling your average down. You're getting more productive in your operation. You're getting more efficient in your operation. Now, when the marginal cost is higher than average total cost, the marginal, every time you produce more units, your average cost per unit will go up because at that point you're not very efficient. And you know that you're doing the best. You're at the most efficient point when both the marginal cost and the average total cost are the same. That is it's a mathematical property, so that happens for Black Duck and it happens for any business. So that is very useful information if you're a manager or an owner, right? Because if you want to know the most efficient point of production, then your most efficient point of production is at the point in which your average cost per unit is the same as your marginal cost per unit. Now, what is the significance of this as to how many workers Mike should hire for making the sandwiches and how big his restaurant should be? That is actually the answers we're going to talk about in the next lesson. Now that we know about costs, we have to bring revenue into the equation, price, to combine them together in the idea of profits. And that's what we do next week.
Produced by OCE Atlas Digital Media at the University of Illinois, Urbana-Champaign.